Foundations of Economic Analysis, written by Paul Samuelson, the Nobel laureate in economics in 1970. Chapter 1, Introduction. The existence of analogies between central features of various theories, the existence of a general theory which underlies the particular theories and unifies them with respect to those central features. This fundamental principle of generalization by abstraction was enunciated by the eminent American mathematician E.H. Moore 30 years ago. It is the purpose of the pages that follow to work out its implications for theoretical and applied economics. An economist of very keen intuition would perhaps have suspected from the beginning that seemingly diverse fields, production economics, consumers' behavior, international trade, public finance, business cycles, income analysis, possess striking formal similarities, and that economy of effort would result from analyzing these common elements. I can make no claim to such. Only after laborious work in each of these fields did the realization dawn upon me that essentially the same inequalities and theorems appeared again and again, and that I was simply proving the same theorems a wasteful number of times. I was aware, of course, that each field involved interdependent unknowns determined by presumably efficacious independent equilibrium conditions, a fact which has always been generally realized. But this leads me to the second fundamental purpose of this work. It had not been pointed out to my knowledge that there exist formally identical meaningful theorems in these fields, each derived by an essentially analogous method. This is not surprising, since only the smallest fraction of economic writings, theoretical and applied, has been concerned with the derivation of operationally meaningful theorems. At least this has been the result of the bad methodological preconceptions that economic laws deduced from a priori assumptions possessed rigor and validity independently of any empirical human behavior. But only a very few economists have gone so far as this. The majority would have been glad to if any had occurred to them. In fact, the literature abounds with these generalizations. We do not have to dig deep to find examples. Literally, hundreds of learned papers have been written on the subject of utility. Take a little bad psychology, add a dash of bad philosophy and ethics, and liberal quantities of bad logic, and any economist can prove that the demand curve for a commodity is negatively inclined. His instinct is good. The attempt to derive a meaningful, useful theorem is commendable, much more so than the innocuous position that utility is always maximized because people do what they do. How refreshing then is a paper like Slutsky's, which attempted, with partial success, to deduce once and for all the hypotheses upon price, quantity, budget behavior implied in the utility approach. The economist has consoled himself for his barren results with the thought that he was forging tools which would eventually yield fruit. The promise is always in the future. We are like highly trained athletes who never run a race and, in consequence, grow stale. It is still too early to determine whether the innovations in thought of the last decade will have stemmed the unmistakable signs of the decadence, signs of decadence, which were clearly present in economic thought prior to 1930. By a meaningful theorem, I mean simply a hypothesis about empirical data which could conceivably be refuted if only under ideal conditions. A meaningful theorem may be false. It may be valid, but of trivial importance. Its validity may be indeterminate and practically difficult or impossible to determine. Thus, with existing data, it may be impossible to check upon the hypothesis that the demand for the salt is of elasticity -1. But it is meaningful because, under ideal circumstances, an experiment could be devised whereby one could hope to refute the hypothesis. The statement that if demand were inelastic, an increase in price would raise total revenue is not a meaningful theorem in this sense. It implies no hypotheses. Certainly not even that a demand exists which is inelastic and is true simply by definition. It may possibly have had a certain psychological usefulness in helping economists ask the right questions but even I have some doubts. In this study, I attempt to show that there do exist meaningful theorems in diverse fields of economic affairs. They are not deduced from thin air or from a priori propositions of universal truth and vacuous applicability. They proceed almost wholly from two types of very general hypotheses. The first is that the conditions of equilibrium are equivalent to the minimization of some magnitude. Part 1 deals with this phase of the subject in a reasonably exhaustive fashion. However, when we leave single economic units, the determination of unknowns is found to be unrelated to an extremum position. In even the simplest business cycle theories, there is lacking symmetry in the conditions of equilibrium, so that there is no possibility of directly reducing the problem to that of a maximum or minimum. Instead, the dynamical properties of the system are specified, and the hypothesis is made that the system is in stable equilibrium or motion. By means of what I have called the correspondence principle between comparative statics and dynamics, definite operationally meaningful theorems can be derived from so simple a hypothesis. One interested only in fruitful statics must study dynamics. The empirical validity of fruitfulness of the theorems, of course, cannot surpass that of the original hypothesis. Moreover, the stability hypothesis has no teleological or normative significance. Thus, the stable equilibrium might be at 50% unemployment. The plausibility of such a stability hypothesis is suggested by the consideration that positions of unstable equilibrium, even if they exist, are transient, non-persistent states, and hence, on the crudest probability, calculation would be observed less frequently than stable states. How many times has the reader seen an egg standing upon its end? From a formal point of view, it is often convenient to consider the stability of non-stationary motions. In good part of part 2, the dynamical behavior of systems is analyzed for its own sake, regardless of implications for comparative statics. And in the last chapter of part 1, I have gone beyond the original conception of the book to include such subjects as welfare economics. Although the logical content of enunciated here is different, there is an underlying unity of method. In the beginning, it was hoped that the discussion could be made non-technical. Very quickly, it became apparent that such a procedure, while possible, would involve a manuscript many times the present size. Moreover, I have come to feel that Marshall's dictum that it seems doubtful whether anyone spends his time well in reading lengthy translations of economic doctrines into mathematics that have not been made by himself should be exactly reversed. The laborious literary working over of essentially simple mathematical concepts, such as is characteristic of much of modern economic theory, is not only unrewarding from the standpoint of advancing the science, but involves as well mental gymnastics of a peculiarly depraved type. On the other hand, I have attempted to avoid all mathematical flourish, and the pure mathematician will recognize all too readily the essentially elementary character of the tools used. My own interest in mathematics has been secondary and subsequent to my interest in economics. Nevertheless, the reader may find some parts hard going. To lighten the way, I have placed the purely mathematical theorems in 2 separate appendices, of which the second gives a reasonably self-contained introduction to the theory of difference equations. The rest of the book, you can read it in the following URL. Thanks for watching.